Okay, so in this video we're going to review quadratics, the zero factoring, and I'm just going to use a few examples. I'm going to use three equations and show you guys how to correctly find zeros. Zeros can also be called roots, and also zeros are going to be the x-intercept of quadratics. So let's say we have the quadratic y equals x squared minus 4. That's a good one. Of course, to find the zeros, what we'd have to do is factor this out, and automatically I can see that this is a difference of squares. So I would put x minus 2, x plus 2. And now, to find the zeros, after you've correctly factored everything out, you have to set the equation to 0. So each individual equation to 0. So x minus 2 equals 0. I'm just going to draw a line to separate that. X plus 2 equals 0. So what we want to do is we want to get the x by itself isolated. So what we're going to do is add 2 to both sides. So x would equal 2. And then take 2 away, x equals negative 2. And then if we were to put this on a graph, it would look a little bit like this. So 1, 2, I know this isn't perfect, but so let's just put our lines right there, or our points. And then since this is a positive, it will be opening up like this. And you can see this is actually also symmetric, y-axis of symmetry too. You can kind of visualize folded down. But these points right here is where x is 0. So if you want an example, y equals, let's use 2 squared minus 4. So substitute the y for 0. 2 squared is 4, minus 4 of course gives you 0. And then erase to get some room. And then vice versa, if you wanted to check it again with the negative 2, remember, put the parentheses, negative 2 squared minus 4, so set it equal to 0, and negative squared is always going to give you a positive, so 0 equals 4 minus 4, and that cancels out to be 0. So you can see what the x-intercepts are. That's one example. Another example of this, I have a very small eraser, so it takes me a while to erase. Okay. Another example of this. Let's say we were given something like this. F of x equals negative x. Just adjust my board here, make sure it's not falling. X squared minus 6x minus 9. And okay, there we go. Hopefully that'll do it. So off the bat, what we want to do is find the factors of this given quadratic. And I see a negative lead term, so what I want to do is I want to first of all factor out this negative 1 here. So it's going to change the whole thing. It's going to be x squared. This will turn into plus 6x minus, or excuse me, plus, did I write that down right? Oh, excuse me, this is supposed to be a plus. So yeah, this would be a minus, and then plus 9. So negative 1. So factor this out, x and x. Remember, when we have a negative and a positive, it's always going to be negative, negative. So we want something that gives us the product of 9 and then the sum of -6. So off the bat I can think of -3. And since this is repeating, you don't have to do this twice. All you have to do is set the equation x minus 3 equals 0, plus 3, plus 3, x equals 3. And then on a number line, or on a graph, it would look something like this. So we found x to be 3. So 1, 2, 3, put your point right there. And it is negatively term, so it's going to be opening down like that. And pretty much this is where the x-intercept is, and the 0. If we plug that in, the equation would give us 0. So, and you can check that on your own if you'd like. So the last example I want to give just adjust my board. Don't really have like a professional setup. Let me see. Okay, that's good. Okay, so the last example is going to be y equals x squared minus 2x minus 3. And now we want to find the factors of this quadratic. So off the bat, x, and a negative and a negative is always going to be a plus and a minus. So we want something that will give us the product of -3 but adds to 2. And I can actually think of something 1 and -3. Yep, 1 and -3. So now set both equations to 0. And solve. So, and then this, of course, would be 3. I skipped a step, but you get the point. So, to graph this, what I would do is go 3, 1, 2, 3, right there, and then -1, right there. And look at the lead term. It's always going to be, if there's no like plus sign or minus sign, it's always going to be positive. So, and positives open upwards like this. And again, what this means is if you plug these numbers into this equation, it'll give you 0, which are the x-intercepts, or the roots, sometimes they're called. And that concludes quadratics 0 factoring.